Now let's look at a slightly more interesting case. This time, we're going to say that there is a relationship between x1 and y. So we're going to hold r1, y right there. But we're going to again say that there's no relationship between x1 and x2, and no relationship between x2 and y. So x1 predicts y, x2 does not, there's no relationship there, and x1 and x2 are independent of each other. If we're going to diagram this, right, here's y. Now, I want you to understand this is all the variance in y. And one way to look at that at variance, right, is the square of the standard deviation. And that's what's represented here. Now, x1 explains some of that variance. x2, on the other hand, still independent of the entire model. Now, if we were going to write out the regression equation that results from this, right, it would be expected value of y is equal to beta 1 x1 plus 0, because there's no relationship there, x2, right? So we could just drop that out. It kind of doesn't matter, right? And this is what this looks like. The implications of this are that this part right here of this circle represents the expected the variance in the expected value of y. So this whole thing is the variance in y, the actual variance in y. This is the expected, this is the variance of the expected value of y. Because remember, the expected value of y is only accounted for by x1. All of the rest of this in this equation would come out as error. It'd be some other thing. It's explained by other factors. The only thing that we're explaining in y is this part right here. So therefore, we might consider r squared to be the ratio of the variance in the expected value of y over the variance in the actual value of y. This is why we say r squared is a percent of variance explained. And that's how we treat it that way. So we say the variance in y, x% of it, or r squared percent of it, is explained by our predictors. Now let's look how this equation then wraps out of this. So in this case, r squared, y12, becomes, now we have a relationship here, right? So we hold on to r squared y1, and we say ry2, though, goes to 0. This all goes to 0 because that does, and anything times 0 is 0. And this becomes 1 because there's no relationship between x1 and x2, right? And 1 minus 0, in this case, becomes 1. So r squared, now y12, is just equal to the relationship between our predictor and our outcome variable over 1. Right? Anything over 1 is just itself. This is why the square of Pearson's correlation coefficient for our bivariate regression case is the same thing as capital R squared, our coefficient of determination. This is that special case in this. This is just bivariate regression, which is the same thing ultimately as correlation.